I'll begin this chapter by first retrieving the sample program that we created in Chapter 1. Click on File and then Open, and then you need to find the folder where that project has been stored. I have it stored in a VTC C++ folder, and simply click on that file name and it will open into your workspace. You'll recall that in the sample program we defined and used variables. A few words about what a variable is. A variable is simply a memory location in which you can temporarily store data. The data may be entered by the user at the keyboard, it may be read from a file, or it may be the result of a calculation made by the computer. In this example, we're creating two variables, num1 and num2, to allow the user to enter their data down below. The third variable, total, is the result of a calculation of adding num1 and num2 together. Before proceeding any further, we need to take time to learn how to select appropriate variable names, a data type, and a value for it. First, there are some rules that we need to learn about variable names in the C language. The rules you need to understand to create variable names are as follows. The first rule, and probably the one which is most often confused, is that variable names are case sensitive. This means that the variable name you create has to be spelled consistently throughout the entire program with regards to upper or lower case. Second, variables must begin with a letter. Third, you can only use letters, numbers, and the underscore. No punctuation characters or spaces are allowed in the variable name. The C compiler you are using determines the maximum number of characters in a variable name. In Microsoft Visual C++, a name could not be longer than 247 characters. Of course, you would not want to use such a long variable name, as this will become cumbersome during the execution and the writing of the program. A variable name cannot be a reserved word, sometimes called a keyword. Keywords have a special meaning in C and must be used for their intended purpose. And finally, you can use either upper or lower case, but due to C's case sensitivity, you must be consistent with the spelling of your variable names throughout your program. Ultimately, when you declare a variable, as long as you follow the rules mentioned here, it is up to you as to what the variable name is called. You should use a descriptive name for each variable. The variable's name should help you remember the purpose of the variable. One popular naming convention for variables in a C program is to type the variable name using lowercase letters. If the variable name contains two or more words, however, capitalize the first letter in the second and subsequent words. Keep in mind that this is just one convention for naming variables. Many others are also used. The important thing is to select the method that makes the most sense to you, and then use that method consistently in all of your programs. Returning to our sample program, notice that I used num1 and num2 to distinguish between the two variables. I used lowercase, and I used numbers simply to identify two different items. Likewise, I used lowercase in my variable called total. Once again, I could have used any combination of spelling here, but consistency is key. In addition to selecting an appropriate variable name, you must also determine the appropriate data type for the variables you create. In the next segment, we will discuss variable types. This chart shows the most commonly used variable data types in C++. Each variable that you create must be assigned a data type. The data type determines the type of data the variable or memory location can store. This is especially important in the language C, as the type of variable that you declare will determine what you can or cannot do with that variable. The character data type, which will use the keyword char, C-H-A-R, and notice that it is lowercase. In fact, all of the keywords are lowercase, can store one character and one character only. There is a string data type that we will discuss later, but for now, the character data type can store one character. There are two different classifications of integers. The short integer, which uses the keyword short or int, int, can store numbers between negative 32,768 to a positive 32,767. The long integers, which uses the keyword long, can store much larger numbers. But in both cases, the only thing you can store in these variables are whole numbers, that is, no decimal places. If your application requires you to use numbers which require decimal points, then you should use either float or double. Float being the keyword and double being the keyword, respectively. As we look at more sample programs, we will discuss more of the different uses for these variable data types. But at this point, keep in mind the various keywords associated with these data types. Here are some simple guidelines to follow when assigning the data type. Assign the short integer, integer, or long integer data type when you are sure that a variable will always contain whole numbers, that is, numbers without decimal points. Which type you choose will depend on the size of the numbers you expect to store in the variable. Assign either the float or the double data type when you need to store numbers with a decimal fraction. Here again, the type you choose, either float or double, will depend on the size of the numbers you expect to store in the variable. Assign the character data type if the variable will always contain one character of data. One last consideration when declaring variable data types, and that is memory. The memory requirement of a data type is an important consideration. If you want to optimize an application's code and thereby conserve system resources, you should use variables with smaller memory requirements wherever possible. For example, although a long integer variable can store numbers in the short range, the long integer data type takes twice as much memory to do so. Therefore, it is more efficient to store a person's age, for example, in a short integer variable. Conversely, you need to use a long integer variable to store the population of a large city. So the bottom line is, the more you know about the data that you're dealing with, the better decision you can make as for the appropriate variable data type. In C++, you must declare a variable before you can use it. You declare or create a variable by entering a C++ statement that specifies both the data type and the name of the variable, as well as its beginning or initial value. Most programmers place the variable declaration statements at the beginning of the program. In other words, as the first statement in the main function. Returning to our demo program, as you can see from our comment, that's exactly what we're doing in this sample, in that we're defining the variables as the very first block of code in our main function. Once the variables are declared, we can now use them in the program. If the C compiler encounters a variable which has not been declared, it will yield an error message. I will look at another sample program which will discuss declaring variables in more specifics and show what happens if you do not declare a variable to have a specific or initial value. I'll be using this demonstration program to illustrate the importance of declaring variables in the proper way. It is also important to note that it is your job as a C programmer to give variables their initial values. If you do not supply an initial value for a variable, the variable will contain a meaningless value, referred to by programmers as garbage. This garbage is the remains of what was last stored in the memory location that the variable now occupies. We can observe this by running this sample program. As you can see, I have declared variables of type char, short, int, long, float, and double respectively. And I've given them appropriate names. Response is my type char, number of hours, type short, and so forth. Note the presence of the blue keywords to indicate that the data type words are in fact keywords or reserved words. The words response, number of hours, quantity, population, sales amount, and total tax are my made-up words. Notice that I have followed the rules and that there are no blank spaces. Every variable begins with a letter, and so forth. Now, what I've done is declared variables, but I have not given them initial values. I'll finish this program to allow me to demonstrate what happens when I don't declare initial values for these variables. The rest of this program is nothing more than a series of cout statements that will display for us on the screen the contents of each variable. The cout statement consists of the word cout followed by the phrase response contains in quotation marks and then the variable response. Recall that my name of my care variable is response. I've done likewise for number of hours, quantity, population, sales amount, and total tax. Each cout statement is followed by an inline statement, which will cause each of these lines to be on separate lines. Let's compile this program to see what it does. We'll click on Build, and then Build once again. You'll notice that after the compile takes place that I receive a message of 0 errors and 6 warnings. The 6 warnings are coming from the fact that I have not initialized these variables. As you can see from the messages, it tells me that my variable response was used without having been initialized. And I get similar messages for each of the other variables. Now these are warnings, which means I can execute the program. So let's just run that and see what happens. And as you can see, the program does run, but what I get in response is the garbage I was referring to. This demonstrates that each variable does indeed contain a value, but you have no control over what that value is. It is very dangerous to do this and to attempt to use these variables in a calculation in a program. As you can see, each variable does have a value. It is most likely the value that you do not want it to have, however. So returning to the program, we should now modify our declaration statements to initialize each variable appropriately. Each variable type is handled differently. For example, the care data type should be initialized to a blank space. It is important to note here that care data types use the single quotes, not double quotes. The double quotes are used with string data types that we've yet to discuss. We will do so later. So we've initialized response of type care to have an initial value of a blank space. We should give number of hours an initial value of 0. Likewise, the quantity should have an initial value of 0, and the population. Each one of these are a type of integer variable, so we're giving them the initial value of 0. Float, on the other hand, should be given the initial value of 0.0, which is the proper way to initialize any variable which can support decimals. Likewise, double can support decimals, so we give that initial value of 0.0 also. Now let's recompile our program to see what change this will cause. As you can see, I now receive 0 errors and 0 warnings. We'll now run the program, and we can see that the program now contains, or now shows, what each variable contains. Response contains nothing, and each of the variables show a null value or a value of 0. So recall that when you're declaring variables, it is important not only to declare a specific data type, a name, but also a specific initial value. This will become more important as your programs become more and more complex. Throughout this course, I'll be following this practice, that is, to declare variables and give them initial values, even if those values are initialized as 0. I have returned to our sample program to demonstrate the use of constants and the declaration of constants. You'll notice I have written some code that will declare 2 constants, one of type char and one of type integer. There is a new keyword introduced here, const. Const is the reserved word that declares a constant. The key difference between a constant and a variable is that a constant's value cannot change while the program executes, where, on the other hand, a variable's value can change anytime during the execution of the program. So in essence, what a constant is a way of protecting data so that the user or the programmer through another line of code will not change the value of this constant. The const precedes the data type of, in this case, char. The word yes in my example is the name of the constant. And then the lowercase y is the value of this constant. So this is the value that I want yes to have. That is the word y. Like declaration statements for variables, you need to end each constant statement with a semicolon. The integer being declared also is preceded by const, followed by the declaration of the data type integer, followed by a made-up name, in this case quota. 100 is the initial value and the only value that quota will have. Again, since this is a constant, this value will always be 100. Once these constants are declared, you can then use them much like you can variables in programs, in that you can use them in calculations, you can display them, and so forth. The key difference, as I've said, is that these values will not change while the program is running. We will be using variables and constants throughout the rest of this course. It is important to understand the distinction now. There are basically two ways that you can enter data into a program. One is to allow the user to enter the data through a series of prompts. That is, using a cout statement, such as you see here, that prompts the user to enter a value, and then follow that with a cin statement, which will accept the data from the keyboard. The operator you use with the cin statement, the extraction operator, which is the double right braces, tells the C compiler to stop reading characters from the keyboard as soon as the user enters the enter key or types a character that is inappropriate for the variable's data type. For example, I have a short variable for num1. So if I run this already compiled program and enter a value such as 5, it returns the value of the variable. If I run the program once again and enter a value which is beyond the range of a short integer, such as 55,000, you'll notice the value of the variable is 32,767, which is the maximum number for this type of variable. Likewise, running the program one more time, and I enter 5,000 for 5,000, you'll notice what is stored in the variable is simply the number 5. The comma is considered an invalid character with a short integer data type, and therefore is not accepted. Everything after the comma is ignored. An alternative to allowing the user to enter data is to assign data to a specific variable through an assignment statement in your code. The syntax of the assignment statement is the variable name on the left-hand side of an equal symbol, followed by an expression or a value. Allow me to present an example. I'll first delete our cout and cin statements and replace it with an assignment statement. Num1 equal, followed by the value that I want to assign num1, in this case 50, followed by a semicolon. Now this serves the same purpose as assigning the value 50 to num1, as if the user had entered 50 when prompted. I'll recompile the program now that I've made this change. As you can see, no errors, no warnings. I'll go ahead and execute it. As you can see, the program does return the value of the variable as being 50. Of course, each time I run this program, I will get the same value since I am assigning a specific value to this variable. The difference between this and a constant, however, is that num1 could take on a different value where a constant is protected. For example, if immediately after assigning the value 50 to num1, I then create a formula such as num1 plus 10, this should now yield the value of the variable num1 to be 60, since I'm assigning the value of num1 to 50, and then I'm adding 10 to it and replacing num1 with a new value, which is the old value plus 10. Let's recompile this program to verify the results. Correct compile, and then as you can see, the value of the variable is now 60. It is important to remember that a variable can store only one item of data at any one time. When you use an assignment statement to assign another item to the variable, the new data replaces the existing data, as in my example here. To complete this example, a better programming technique would be to initially give num1 the value of 0. Therefore, initializing the variable at the same time it is being declared. And then num1 equals 50 replaces that 0 with a 50, and then the assignment statement adding 10 to num1 then creates num1 to be equaling to 60. Of course, whether you use assignment statements or prompt the user using cout and cin statements, the rules of variables still need to be followed, and the syntax needs to be adhered to. This concludes Chapter 2, and in the next chapter, I'll be looking at the string data type and some other functions associated with special data types and equations.